Hello, this video has been created for Mr. Beeler's pre-calculus classes. In this video, we will begin to look at how the law of sines can be used to find missing parts of an oblique triangle. The content of this lesson aligns with Common Core State Standard G.SRT.11, which states that students will be able to understand and apply the law of sines and the law of cosines to find unknown measurements in right and non-right triangles. In geometry, you learned how to solve for the missing sides and angles of a right triangle by using the Pythagorean theorem and the sine, cosine, and tangent ratios. Unfortunately, these techniques that you use in geometry are not applicable to oblique or non-right triangles. To solve for the missing sides and angles of an oblique triangle, we must use either the law of sines or the law of cosines. In this lesson, we will focus on only the law of sines. For a triangle such as the one pictured below, the law of sines is as follows. Sine of A, or angle A, over side A is equal to the ratio between the sine of angle B over side B, which is also equal to the ratio between the sine of angle C and From the law of sines, we can take our three-part equation and derive three separate proportions. So sine of A over A equals sine of B over B, or sine of A over A equals sine of C over C, or sine of B over B equals sine of C over C. In order to use the law of sines, it is necessary to determine which proportion is applicable to the problem situation. We will examine this further in the example that So, in our example, it says a boy is flying a kite at a family picnic. During lunch, he ties the kite to a stake and walks over to the picnic tables 50 meters away. If the angle of elevation to the kite from the picnic tables is 30 degrees, and the kite string is 15 degrees from vertical, what is the distance from the stake to the kite? The diagram below represents this situation. Note that the 105 degree angle is 90 degrees plus the 15 degrees from vertical that was described. So to start this problem, in step 1, we want to start by labeling the vertices and sides of the triangle. We use uppercase letters to label the vertices, and it doesn't matter which vertex is labeled A, B, and C. You can label those how you want. Okay, once you've done that, we use lowercase letters to label the sides, and those lowercase letters have to go opposite of their corresponding uppercase letters. So for instance, the side that runs from the kite to the stake would be side A. The side that is 50 meters is opposite of C, so that'd be side C, and so on. Now, step 2, we want to determine which part of the triangle we're trying to solve for, and then which proportion we can use to solve for that part. So, since we are trying to find the distance from the stake to the kite, the part that we are trying to solve for is side A. Thus, the proportion that we can use is either sine of A over A equals sine of B over B, or sine of A over A equals sine of C over C. However, at the moment, we cannot use either because we do not know the value of little b or the value of big C. We will need to find the value of one of them in order to proceed. Which one can we find? Well, since we know the values of A and B, we can very easily find the value of C by subtracting A and B from 180. Thus, angle C equals 180 degrees minus 105 degrees minus 30 degrees, which equals 45 degrees. And thus, we can use the proportion below to solve for little a. Sine of A over little a equals sine of C over little c, because we now have both. So, step 3, we substitute our values into the proportion and solve for a. So if we substitute in, we have sine of 30 degrees over little a equals sine of 45 over 50. Cross multiply, we have a times sine of 45 equals 50 times sine of 30. Divide both sides by sine of 45, and we get 35.36. Thus, the distance from the stake to the kite is 35.36 meters.